This is either going to be amazing or I'm definitely going to die. Pray to Metallic Ore, the god of machining. Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to make a die stock. It's kind of like a wrench that holds round dies, allows you to cut threads by hand or also on the lathe. And I'm going to make this entirely on the lathe. This is a great project for people that are just getting into machine tools. And just for fun and to challenge myself, I'm going to make it entirely on the 4-jaw chuck. That's the only work holding we're going to use for this entire project. It's going to be fun. Let's go. Here's an example of the dies that I'm making this for. There are dimples on either side for retaining the die, and then there's a split which is retained with a set screw. Now often you'll see a third set screw on die stocks that have a point on them, and it's for wedging into the split here to keep that from closing up as you tighten the other set screws. And these dies don't need that because they have the set screw in there, but that is an option if you want. There's room for that in the design. Here's my design for a die stock that we can make entirely on the lathe. The sides of it are quite beefy for such a small die, and that's because we need the space on either side for the handles to thread in and be counterbored for alignment. So you can see that the center section here has threaded holes on the sides with the little counterbores there, and then there's set screws on opposite corners for holding the die in place. It's never a bad idea to leverage the parametric features of modern engineering software, but for something like a die stock, it's especially powerful because I can change one number here and now I have a die stock for 2-inch dies. Or for metric, I can go 45mm. It's all unit agnostic, of course. So this is all on my Patreon. If you're interested in making a die stock for whatever size dies you need, go check that out. I raided the junk bin for this and I found a nice little stub of 12L14 and this longer mystery steel. It's rusty, so I know it's not stainless. The end on it is pretty rough. No idea what that is, but let's see how it machines. I always like making things that use up scraps of mystery junk because, I don't know, it just makes me feel like I'm creating things without putting more junk into the world. So I'm going to dial in this guy on the 4-jaw. Of course, we're going to do this whole thing with the 4-jaw, as I said. So get used to dialing things in because we're going to do that a lot. And I will face this off, as is tradition. Most of the stock is inside the spindle bore, but I'll pull out just enough of it for the first handle here. And then, of course, you have to dial it in again. As soon as you touch the jaws, things are going to shift a little bit, but if you're careful, you can usually keep it within a couple thousandths each time. And just checking on the straightness here, and you can see that we've got about quite a bit, 15 thou, maybe a run out at the other end. So either the bar is bent, or it's crooked in the jaws, or some of both. So I'll start by tapping it in and see if I can straighten it out in the jaws. And it got a little better after I did that, but not much. It gets to the point where it won't move anymore in the direction that it needs to, and that means there's just frankly a bend in it. So we can deal with that though. We're going to be machining the OD anyway, so we can take that bend out. However, we need to make sure that the bend doesn't interfere with the tail support. So it's best to center drill it with the stock pulled out like this, and then the center will be true even though the bar has a bend in it. You can see this in action here. Once I get the live center in there, you can see once I spin it up that there's a wobble in the middle where the bend is, but the tailstock isn't moving. If you do this wrong, if you, for example, put the center in it while the stock is choked up in the chuck, then when you pull it out and put the tailstock in, the tailstock will be wiggling because that center wasn't on the center of rotation of the bar at that length. Okay, first cut here. I've got my go-to high-speed steel cutter here that I use for steel. And this is cutting pretty decently. It's mystery steel, so you never know. This is clearly some kind of mild steel. It's cutting fine, but the surface finish on it is not great. So after that first pass, I switched out to this new insert that I've been using at the recommendation of my viewers. It's actually an aluminum grade insert, but on small lathes it works really well on mild mystery steel. And the finish on that is great, though it's very hot. So I let that cool down and then take a measurement here, and that'll tell me how much I need for my finishing pass. On a long part like this, I always measure in multiple places just to see if there's any taper in it. And then I go to a very slow feed, very high RPM, and let that run all the way down for a nice finish. And this is going to take a while because it's a pretty long part. Next I need a little shoulder at one end, so I just touch the cutter lightly on the end of the part there, and then I'm going to set up an indicator on the carriage. And then I can zero out this indicator, pull the cutter off the work, move it over the depth of the shoulder that I want using the indicator to measure the precise distance there. And then I can pull the indicator off of the carriage and then put it back on with a light preload and zero it right there. And then I know I can just take each pass up to the 0 on that indicator, and that saves me having to worry about counting how many laps the needle has done and that sort of thing. It's just an easy way to, eliminate errors when turning to a shoulder like this. So a couple of passes will get this down to the major diameter I need for my thread. And then on my last pass, I lock the carriage and wind slowly out to clean up the shoulder, and everything should be nice and on dimension. And then I'll just break those edges there with a file as well. And then I'll put the threads on the end here with my tailstock die holder. And know the irony of using a die holder to make a die holder is not lost on me. If you don't own a die holder and this is the very first one you're ever making, then I don't know, I guess you got to single point cut these threads. This shoulder needs to thread tightly into a counter bore, so it's a good idea to undercut the base of the thread to make sure that it's going to seat tightly all the way down, make sure there's no fillet in there. So I'm coming in with a very sharp nosed tool and just undercutting that area above the thread a little bit. There's no such thing as a perfect inside square corner in the real world, so we undercut things that need to sit together. And then I'll part this off to length, just using my eye and a good quality scale for the length here. The length of the handles doesn't need to be to the 1,000th precise. If you measure the length of the handles on my die stock with a micrometer, you are getting kicked out of my shop. Parting mystery steel is always a little bit hair-raising. This is where you find out if it's going to bite you or not. Sometimes it'll machine okay and then just explode when you try to part it, but this actually went pretty well. It's fighting me a little bit, but Yahtzee. Then activate the bar feeder and make the second one the same way. Bring it to the same point. Now with both of them done to that point, I can put them back in, flipped around the other way, and I've got some shim stock on there to protect it from the jaws. And I'm going to dial that in again, and now we're going to finish up this end of it. So I'm going to put a nice rounded end on the end of these so it'll be nice and comfortable to use. So for that I've got a form tool here. Now using a form tool in mystery mild steel on a small lathe is really asking for trouble, but you can sometimes get away with this, so I'm going to try it. So I'm going in, feeding very, very slow, and the more the tool gets engaged, the slower I run the lathe. So towards the end here, I'm down to about 90 RPM, very, very slow, just to keep it from chattering, and lots of cutting fluid, and I did indeed get away with this. And that form tool, by the way, was just made with a Dremel sanding drum, just held at an angle to get clearance on the underside of it. Now, if I had not gotten away with that, then what you can do is do some step turning on the surface first to create the rough profile that you want, and then go in with the form tool just to clean it up, because then the form tool isn't doing as much work. It's all about keeping the tool pressure as low as possible. So then I went in with a file and just blended everything together, because the radius of the form tool wasn't exactly perfect for the diameter of the stock. The finish on that is okay with that insert that I used, but I'm going to improve it a little bit further, I think, just to make it a little nicer. So pull it out a little bit, and I got some protection on the ways there, oil it up, and I'm going to come in with the 320 grit emery cloth and just polish that up a little bit, smooth that out a little bit all the way down the length of it there. And then I also came back in with some 800 and polished it up a little further as well. And then you can flip it around and do the end that was in the chuck the same way. You don't have to dial it in for these steps when you're just using emery cloth. It doesn't matter if the part is running true or not. On to the body of the die stock now. I've got this scrap I showed earlier, but it's too big. I'm gonna need a bigger chuck, I guess. Well, that's frustrating. Imperial fist shake. Oh, wait, these adjust. Okay, so I'm gonna move the jaws out and dial this guy in as well, of course. This is a leftover stub from 28 previous projects, so it's got a whole bunch of weird random diameters on it that I'm going to face all the way down, as is tradition. And then once I've got one nice clean face on it, for the final finishes I used the power cross feed, because you want to feed very slowly, which gets old pretty fast, even on a 2-inch diameter like this. And then I score up the tool post using the face of the work, which is now nice and square, might as well. And that will allow me to get in here with the chamfer tool now. And this is the back of the die stock body, so I can put a really generous chamfer on here. I can have a little fun with it. You can get away with this to a point, but if you want a chamfer much bigger than this, you need to single point cut it by using the compound. I'm going to reference that back to the chuck face now, and so I've flipped the jaws around and I'm going to hold it using the outside jaws like so for the rest of our operations. This is going to let me machine it down to quite a thin dimension while still being able to access it. So I need to dial it in here once again, of course, but I won't need to move it again here for quite a while after this. Now the stock is quite a bit too thick, so I'm going to face it all the way down. It's kind of right on the edge of where it was worth getting out the saw to cut off the excess. It's going to be a lot of chips, but it didn't quite feel like it was worth cutting it off. So I'm just going to face it all the way down, and this will be the last job that this stock is ever used for. It served us very well. Now, unfortunately, I can't get my calipers in there to see how close I am. I know I'm close, but I got to take it out for a measurement for the final pass. So take it out, figure out how much I got to take off, and then put it back in. And this is the final cut, so I want it to be nice and parallel. So I'm going to tap this in, make sure that my reference face is seated well against the jaws there. And then to do this dialing in, I got to get in a different indicator tip here so I can sneak in behind the spinning wings of death there. You always got to be careful with the forejaw working in this position. And then I'll tap it in one more time and then check it with the indicator one more time, because anytime you touch anything, something else might have moved. So you got to go back and forth checking everything until nothing moves. And then I can come in here and break this edge after that final cut. And now we can start putting holes in it. So there's the first hole, center drilled and pilot drilled, but I'm getting into trouble here because the jaws are closed up behind the work here. So if I go in with larger drills, I'm going to hit them. So I need basically a drill with no point on the end, and for that I've got this guy right here. This is a DeWalt drill that has a flat grind on it, and this is going to allow me to go through the stock without breaking through to the other side with a big point that would hit the chuck jaws. You could also grind a drill like this, or use a 2-flute end mill, or make the hole in the previous setup before we flipped the jaws around, which would have been a lot easier. Precision depth is going to be key here because I don't want to go too deep, so I'm setting up an indicator on the tailstock quill here, and I just touch up the drill, zero it right there, and then I can come in with this flat grind drill. And because the grind on the drill is flat, you can see it wanders quite a bit when it starts, but that's okay because we're going to be boring this. This is just a roughing operation to get most of the material out of the way. And that makes it just big enough that I can get my smallest boring bar in here. And then we can open up this hole to the final dimension required by the drawing. The idea here is that this is a pass-through for the largest stock that you might ever want to cut a thread on, which in this case is 1/2 inch because it's a 1-inch die, and that's the biggest thread that you can cut with a die that size. So I'm making this hole a little bigger than 1/2 inch so that you can pass material through it as needed. We have a long way to go, but now it's big enough where I can switch out to my larger boring bar so I can take heavier cuts, and oh, nope, not quite gonna fit. Okay, back to the little one for a little while, and widen this guy up a couple more passes, and now I can come back in with the big one and finish this out to size. Should be close now on the diameter, so out comes the telescoping bore gauge, or the snap gauge as I like to call it, to engage the trolls. And that tells me how much I need to take off for my finishing cut, and I've also stopped a few thou short on the depth, so I'm going to check how much further I need to go there, and then I do both of those finishing cuts in one operation. So I go all the way in to 0 on my indicator with the boring bar, and then I lock the carriage and I wind in with the boring bar to finish that back face, just like you would with turning to a shoulder, but kind of in the negative aspect, something. In science-y words, you get the idea. The result looks very nice. It should be right on dimensions, so I can deburr that, and let's do a little test fit here with the die and see how we did. Survey says, ooh, not quite. We're just a hair too small, just the tiniest little bit. So what it needs, I think, is a spring pass, because normally you do 2 passes with the boring bar. You go in and you go out, and the spring pass kind of finishes at 2 dimension because boring bars have a lot of flex in them. But when you do that final pass on both surfaces, you don't get that spring pass on the way back. So I just go in with the boring bar to the inside corner again without changing the setting on it at all. It's exactly in the same place as it was when I did that surface previously. Go in, come back out again, and now the die fits perfectly. Oh, mercy, that's a good fit. Moments like this are why I like machining. That is just so incredibly satisfying. Let's see how we did on depth. And yeah, the scale sits perfectly across there. It's not proud of the surface. And if I reach in there and try to pull the die out against the ruler, I can't. So it's basically sitting exactly in the right place. Wow, I'm very pleased with that. Now let's get crazy. So I'm going to put this thing in the four-jaw edge on, like so, and we're going to make the holes for the handles. So you dial in the sides of this just like you would a square part. You rotate it back and forth till the needle stops moving, and that tells you when the surface is vertical, and that gives you a reading. And then you flip it over and do the same thing on the other side, and that gives you a reading. And then you use those two readings to dial it in on that axis, just like you would with a round part. You just have to be a little more careful about how you flip it back and forth. For the other axis, we can do the same thing, but we can't access the side of the part. So instead, we're using a chord of the circle across the part. And you can do this as long as you're very careful that nothing moves in your setup. So don't move the indicator, don't let the part move in and out of the chuck, and so that you're always on that same circle chord. If you do this carefully, you can get away with it. And then after doing one axis, you got to go back and check the other one because it's likely to have moved. And you go back and forth until everything is dialed in on both axes. And then we can spin it up and see how it looks, and that is looking good. One cautionary note here, you really only want to hold round things sideways in the jaws like this if the jaw is at or over the center line of the round part, because otherwise you're holding it behind the curve, if you will, and you don't have a secure grip, and it's going to shoot that part out of there like a wet hot dog. Now you can get away with this to some degree if the other two jaws have a good grip, but just know that your part is not very secure if the jaws are not over the center line of the round surface. So that setup is fussy, but once it's done, we can proceed as if this wasn't a crazy round part sitting sideways in a four-jaw chuck. So I can center drill that, and then once again, we're going to need very precise depths here because we got to make these blind holes as deep as possible without breaking through into the center bore there. So then we're going to follow the drawing to the letter here, and we want these depths precise to the thousandth if we can get it. And of course we're going negative here, we're pulling away from the indicator, so that's why the indicator was preloaded all the way up. Once we're at depth with the tapping drill, then I can come back in and tap those threads for the handle all the way down. This hole is so shallow, so I go straight in with the bottoming tap. There's no point even trying with the taper tap, it's never going to even start. Quick test fit of the threads with the handle, and that looks good. Of course, the handle won't seat down all the way because we haven't counterbored that yet, so that's next. Luckily, this hole is just big enough that I can get my little boring bar in there, so I'm going to counterbore this out for the handle. And this looks nice, but it's more than just aesthetic. It's also going to hold the handles in alignment and add a lot of strength. So it's not just the threads that are holding the handle in there. The handles themselves are going to have a positive registration against the body. And the fact that a counterbore can hold the part in alignment is going to serve us very well here in a minute, as you will see. Moment of truth. Let's see how the handle fits in there. It should disappear completely into the body if we did our homework, and that is looking really good. Threads in there real nice, and oops, yeah. See, that chamfer was not actually in my drawing. I went off script there and didn't account for how it was going to expose part of the counterbore there, but well, other than that little space there, we'll see if the inspector notices it, but otherwise it's looking good. So now I can pull that out of there, and remember how I said that counterbore is going to serve to align the handle? Well, here is how we're going to leverage that. So now I put it back in the other way, and I'm going to use the handle to align the other handle at 180 degrees opposed. So I dial that in. You might think I'm crazy, but bear with me here. This is not as crazy as it looks. So what I'm going to do is just center drill that, and then I'm just going to put a little tiny pilot hole to the final depth of the counterboard feature here. I'm not going to do all of the machine work on this side with this crazy setup. I'm just putting a little pilot hole in there. And then I go and find a gauge pin that's a good fit, and that one's too small, go up a little bit, and that is a good fit. This is 3 thou oversized because it's a drilled hole, so that's about what you'd expect. Now, I can take this out of this Maniac setup and take the handle off, and now I can put my gauge pin into that hole and use it as a reference. So I just used that fragile setup to establish my reference. And now I can make a sturdy setup to do the actual machining using that reference. So I put the gauge pin in my tailstock just to get me in the ballpark here. And then I'm gonna get my shim stock back in there to protect the work. And then I'm tightening this up very lightly. You don't want to tighten it up firmly because you'll risk bending the gauge pin because you're unlikely to tighten it up perfectly on all sides. So just lightly, and then tighten the jaws up, and now dial it in using that pin. Easy, right? Dial in the pin and we're done? Well, not quite. As you can see, the part is actually still crooked in the jaws. The end of the gauge pin there is wiggling around. So I had to come back in, loosen it a little bit, and shift it slightly in the jaws. After I pulled the tailstock out, it must have shifted a little bit. So I wiggled things around a little bit, tightened things up again, and I dialed it in on both the far end and the near end of the gauge pin and just went back and forth until I had it running as true as I could get it. It's not perfect, but I got as close as I can here with this method. Spin that up, see how it looks. It's not perfect, but it's pretty good. More than sufficient for the handle on a die stock. And drilling, threading, counterboring just like on the other side. Now we need the little threaded holes that are 90 degrees opposite the handles for holding the die in place. So I'm going to blue up the general area where those need to go. And these need to be, roughly 90 degrees off of the handles, but they don't have to be precise. So I'm going to do it on the surface plate, and I use the handle to just eyeball the top vertical there. And then I'm going to use my height gauge to find the top surface, and then I come down the radius of the part, and I'm just going to scribe that line right there. So that's going to be a center line that's pretty close to 90 degrees off of the handles. And then for the other dimension, I'm going to find the top of the part, and then I'm going to come down half the thickness of the dies so that the set screw ends up on the center line of the dies themselves, which is different than the center line of the die stock body. And scribe that, and there is our center. Now I can center punch that, and we're ready to go. Now I'm going to dial in this punch mark, but there's something important to understand here. It's not enough to get this punch mark on the center axis of the lathe. You also have to have this punch mark on the outermost part of the curvature of the stock. Otherwise, you're centering your punch in the wrong place. So you need to have some way to reference the punch mark on an imaginary line going through the center of the die stock. So in this case, I'm using the counterbores that we made, and I've lined them up on the top and bottom jaw of the four-jaw chuck. However, if you weren't able to do that, depending on the part you were making, you could also scribe a center line and then line up that center line so that it's horizontal with something on the lathe, something like that. This is not the most precise way to do a feature like this, but for something like a die stock, it's sufficient. If you needed a high precision version of a feature like this, you'd probably want to set it up on the mill where you can control the references much better. Or if you needed high precision and you needed to do it in the four-jaw, then you're probably looking at building a fixture that can reference the other features of the part to the chuck. So now I can bring in my dead center, which if you've never noticed has a center in the back of its own, and I can use this to align my punch mark on the center axis of the lathe. So I pin it between the punch mark and my live center, put the indicator on that, and then dial this in just like any other part. I have that board down there because it is possible for the dead center to fall out while you're doing this if you're not careful. I'm doing it this way because the punch mark is not centered on the body like the other features were. However, you could also do this with an indicator. Just when you dial it in, bias your indicator readings to one side to shift the hole that you're going to make to one side. Now once again, we need two of these holes 180 degrees opposed like with the handles. However, these are through holes, so I can just drill both of them straight through all the way. And while I needed to center drill the entry point because that's a convex surface, the hole on the other side is a concave surface. We're coming at it from the inside of the bore, so that's going to self-center and the drill can engage the material on the other side just fine. Then I can keep it in this setup and tap the first hole. Then I flip it around and just roughly position it with the gauge pin trick again. Just close enough is fine here. The tap will find the right place. And you could even tap that by hand if you wanted. You probably noticed I never did machine the OD, and that's intentional. I just went with the OD of the round bar that I had because this outer surface doesn't need to be precision, and it saves me making a lot of chips. And then a little polish on the Scotch-Brite wheel. It's looking pretty good. All right, test fit time. I should be able to put both handles in, and I got some little bolts there that I just cut to length to use as set screws. I just filed a little dog point on the bottom of each of them. Die goes in, set screws go in, and that is looking suspiciously like a die stock. I think that will work. Okay, finishing and final assembly. I'm going to clean everything up with acetone. I'm going to leave it bright finish because I think it turned out nice visually. And I put some Loctite on the threads. That'll keep those handles from loosening, but I can still remove them if I ever want to. For finishing, normally Bow Shield T9 would be my go-to, but CRC sent me this stuff. I'm going to give it a shot. Full disclosure, they sent me this for free, but no strings attached, so I guess that makes me some sort of corporate sellout. I don't know. What happened to you, Quinn? You used to be cool. Wait, no, I was never cool. All right, I'll try this stuff, and if it sucks, I'll tell you. There it is. I'm really pleased with how the handles turned out. They have a real beefy feel to them, plenty of leverage, lots of strength there, and well, good for light murder as well. So let's give this thing a test run. It works as expected on the lathe in manual usage. It's got the pass through there, and I can cut a very long thread on the stock as hoped, but I also wanted to make this thing extra beefy so that I could try using it under power. So let's do that. And that's working quite well. I tried a couple of different positions on the board here, and you do have to be careful. The board has to be slippery, otherwise the handle can get caught up, and you gotta kind of keep it moving, but you know, without getting your fingers anywhere near there where they might get squished. This worked surprisingly well on my little 1 horsepower lathe. It's working really hard, and there's lots of smoke, but it does cut quite a nice thread very, very quickly, so I'm pretty pleased with that result. This was a fun little project. We got to try some interesting things on the forejaw, and now I have a terrifying new way to make threads under power in a very, very fast way. I hope you enjoyed this project. If you like these videos, throw me a little love on Patreon. There's a link in the description, and there's a card here on the screen. Thank you very much for watching, and I will see you next time.